Sathyabama Institute of Science and Technology.
Hello, this is Srividhya, Assistant Professor, Department of Mathematics, Sathyabama Institute of Science and Technology, Chennai. Today, in this lecture, we shall see what is discrete random variable, the problems based on discrete random variables. So let us see this as an example. A discrete random variable x has the following probability distribution. So we are given a random variable and a probability values are given. Okay. Now we shall find the questions which are given here. That is number 1, find the value of a, evaluate probability of x is greater than 3 and evaluate probability of x less than 3, probability of 0 to 3, the probability of x greater than or equal to 3, and also find the mean, variance and cumulative distribution function. Okay, so let us see one by one. These are the probabilities given. So which takes the random variable x, and this is the probability which are given in terms of a. So we need to find the constant a first. So we know that in a discrete case, it takes a possible real value, direct value we can take. So according to the probability properties, we shall use, if probability of x is a mass function, that is probability mass function, then the property would be summation x is equal to minus infinity to infinity probability of x is equal to 1. So this is a discrete case. We shall add all the probabilities which is equal to 1. It gives you the value which is equal to 1. When you add the total probability, it should be 1. So we shall add all the probabilities given, that is p of 0, p of 1 plus and so on, p of 8 which is equal to 1. So inside the brackets they are all random variables and we shall use its probability and add. So p of 0, the probability is a, p of 1, the probability is 3a, p of 2, the probability is 5a, and so on. We have till p of 8. So let us add all the probability values and make it is equal to 1. Then all the values coefficient is a. So let us add all the values. 81a we are getting, and which is equal to 1. Then you can bring the coefficient to the other side. It becomes a is equal to 1 by 81. Then the probability distribution table becomes, we can write the probability table again, distribution table again, by substituting the value of a. So in this question, we shall substitute in the place of a 1 by 81. If you substitute, your probability distribution table would be like this. That is 1 by 81, 3 by 81, 5 by 81, 7 by 81, 9 by 81, 11 by 81, 13 by 81, 15 by 81, and last one 17 by 81. Number 2, we have to evaluate the probability of x is greater than 3. So what is p of x is greater than 3? Which is not possible if you have a large number of data. So it is easy when you use the formula or identities. So let us evaluate probability of x is greater than 3. So probability of x is greater than 3 would be 4, 5, 6, 7 and so on. So if the data set is large, we cannot make use of it easily. So we can use the formula, that is p of x is greater than a, which is equal to 1 minus p of x is less than or equal to a. So when compared to that one, this one will be easiest when we apply smaller values. So we can write this as 1 minus p of the probability of the value which takes less than or equal to 3. So what are the values which are less than or equal to 3 in this table is x takes the value 0, x takes the value 1, x takes the value 2, and it is equal to 3. So we can take 3 also. So p of 3. So we shall substitute what is p of 0 from the table which we got, probability distribution we got, no, that value we can substitute. So p of a is p of 0 which is equal to a, p of 1 is 3a, p of 2 is 5a, and p of 3 is 7a. When we add all these a's, we will be getting 16a. Then we can substitute the value of a which we got earlier, which is 16 by 18, that is 1 by 81. If you substitute there, 16 by 81. When we take LCM and find the value, you will be getting 65 by 81, which is the probability of x greater than 3. there is a chance. How much chances are there now? 80 point. When we divide it, we will be getting 0.80246, which is nothing but 80.246 chances are there for the probability of x greater than 3. Next is we shall find a p of x is less than 3. So what are the possibilities of x takes the value less than 3? That is p of x is equal to 0, or p of x is equal to 1, or it could be p of x is equal to 2. So we can write in terms of r, we can write plus. So p of x equal to 0 plus p of x equal to 1 plus p of x is equal to 2. Again we are applying the value of the probabilities, and substituting the value of a, we will be getting 9 by 81, which is the probability of x less than 3. Next is probability of 0 less than x less than 3, which is equal to what are all the values lying in between 0 and 3, that is excluding the 0 and 3, because there is no equality here. So excluding 3 and 0, we will be able to write this as probability of x is equal to 1 or probability of x is equal to 2. So we can write under plus p of x is equal to 1 plus p of x is equal to 2. That is 3a plus 5a, which is equal to 8a. Applying the value of a, you will be getting 8 by 81. Next is the probability of x greater than or equal to 3, which is nothing but greater than or equal to 3, as I told you already. If we have a larger number of data, we cannot find it easily. So we find the easiest way, that is p of x is greater than or equal to 3, which is equal to 1 minus p of x is less than 3. So we have the value already, which is probability of x is less than 3, which is 9 by 81. So if we substitute there, we will be able to find the probability value as 8 by 9. Next is to find the mean and variance. We know that mean is equal to expectation of x, which is the expected average, which is equal to summation x into p of x. That is a random variable x which takes and its probabilities under product. So E of x squared is equal to E of x squared is equal to summation x squared p of x. So we need to find its variance. So we need to use the value expectation of x squared minus expectation of x the whole square. Now let us find mean. Mean is equal to x into p of x. No, what is your x? X is equal to 0 and its probability p of 0. We can make use of probability of 0 value here, multiply them, and plus next value would be 1 into p of 1 value is 3 by 81 plus 2 into 5 by 81 plus 3 into 7 by 81 and so on. So like this we can substitute all the random variables and its probabilities. After adding them, we will be getting 444 by 81. When we divide it, which is 5.4814. The expectation of x is 5.4814, which is nothing but mean. Next, we want to find variance. For finding variance, we need to find expectation of x square. So we shall use this formula for expectation of x square, that is summation x square p of x. When we apply x is equal to 0 and square it and multiply its probabilities, that is 0 square into probability of 0 is 1 by 81 plus 1 square, probability of 1 is 3 by 81 plus and so on. When we do like this, we will be adding all these values, then we will be getting 2796 by 81, which is nothing but expectation of x squared, which is nothing but 34.5185. Now we can substitute this in the formula variance. Variance is equal to E of x squared minus E of x the whole square. So E of x squared value is 34.5185 minus 5.4814 the whole square, which is equal to 4.4727. Next is we have to find the cumulative distribution function. The formula for cumulative distribution function f of x, which is equal to p of x is less than or equal to x, which is nothing but the summation minus infinity to x p of x. This is the formula for finding the cumulative distribution function, which is denoted by capital F of x. Now we have the random variables, we have the probabilities. Now we want to add all these probabilities to find the cumulative distribution function. Now take your first value p of 0, which is equal to 1 by 81. Now we need to find f of 0. F of 0, which is equal to p of 0 by the property of a probability distribution, cumulative distribution function. f of 0 is equal to p of 0, which is equal to, both are same, so 1 by 81 we can write directly. Then we can add the successive values to find the cumulative. Now let us add 1 by 81 and 3 by 81, which will give you 4 by 81. Then for this value x is equal to 2, f of 2, which is nothing but f of 1 plus p of 2. We can add these two values, 4 by 81 plus 5 by 81, which is 9 by 81. Next is to find the probability value, that is cumulative distribution function of x is equal to 3, that is p of 3 is equal to 7 by 81. When we add these two, we will be getting 9 by 81 plus 7 by 81, which gives you 16 by 81. Next is probability of 4 is equal to 9 by 81. Then you can add this value and this value, that is f of 3 plus p of 4, which gives you 16 by 81 plus 9 by 81, which is 25 by 81. Similarly, we can add all the successive terms. At last, we will be getting 81 by 81. The total probability should be equal to 1. At last, we should get the cumulative value to be 1. Thank you.